Our next lesson is called Graphing Quadratics from Factored Form. I'd like you to start with the opening exercise. It says solve the following equations. There's just one there. You're going to solve x squared plus 6x minus 40 equals 0. Please pause the video, do the opening exercise, and resume when you're ready to go over the answers. Okay, now that you've had time to try the opening exercise, you can check your answers. X squared plus 6x minus 40 is a trinomial with an a value of 1. So you're looking for the factor pairs of negative 40. That would add up to positive 6. So that's x plus 10 and x minus 4. Set each factor equal to 0 and solve. You get an answer of x equals negative 10 and positive 4. Now in example 1, it says consider the equation y equals x squared plus 6x minus 40. So we've replaced the 0 with a y. It says, given this quadratic equation, can you find the point or points where the graph crosses the x-axis? So remember, if you're looking for where it crosses the x-axis, you are looking for the roots, okay, or x-intercepts. To find an x-intercept, you have a y value of 0. So we've actually already found the roots. If we had replaced y with a 0, which is exactly what we did in the opening exercise, and we solve, we know exactly where the function has y values of 0. So the answer here is at, now we're going to write these as coordinates. If x was negative 10, that's negative 10, 0. And if x was 4, that's 4, 0. And again, these are called the roots. And we want to make sure we understand how we got those. So this is where y equals 0. So 0 equals x squared plus 6x minus 40. Now, if you had just been given this question to start, you would have set it equal to 0 and solved it like you did in opening exercise A in order to find the answers. Now in B, how can we write a corresponding quadratic equation if we are given a pair of roots? So we are going to use the zero product property to basically work backwards. So let's say we already had the roots. That's what this question is saying. So you have a pair of roots. So for us, it was negative 10 and x equals 4. Let's say they gave us the roots first instead of having us solve the quadratic. Well, how do we work backwards from that? Well, think about this, how the zero product property works. In order to get x equals negative 10, we solved from something set equal to 0. So we must have solved x plus 10 equals 0 in order to be able to subtract 10 and get that x equals negative 10. Similarly, for x equals 4, working backwards, we must have moved that 4 to the other side from being set equal to 0. So we must have solved x minus 4 equals 0 by adding 4 to both sides and getting x equals 4. That then gives me the two binomials, x plus 10 and x minus 4, that would have to be used to create the quadratic equation. So this is kind of an example of working backwards. So let's put working backwards. But we're still thinking of that idea of the zero product property. Now in part C, it says, in the last lesson, we learned about the symmetrical nature of the graph of a quadratic function. So remember, when we graph a quadratic, it looks like this. There's a turning point here called the vertex. We went through all those details, and it is a symmetric picture. How can we use that information to find the vertex? So how does the symmetry of this graph help us find the vertex? Well, we can take our roots and we can average them. That's something that we actually talked about when we were exploring all the properties of the quadratic. So our roots were negative 10 and positive 4. So we're going to add those together, and then there's two numbers, so we're going to divide by 2 to take the average. This would be negative 6 over 3, which means this equals negative 3. So that tells me x equals negative 3, now remember. So here, why don't we write that we are averaging the roots. So now that we know that x equals 3, because we took two x root values and we averaged them and got x equals 3, we're going to use that number to help us find the vertex. Now remember that the vertex should be a point. So we need an x and a y, and currently we only have an x. But we do have the equation from B that we could use So we're going to use the factored form. Instead of 0, we're going to put y, and we're going to use the x plus 10 and the x minus 4. We're going to use the factored form. So y equals, we're going to plug in negative 3 for x in both places. So that means y is equal to negative 3 plus 10 is negative 7. Negative 3 minus 4, negative 3 plus 10 is positive 7. Negative 3 minus 4 would be negative 7. So when you multiply these, you end up with negative 49. So now I know that my vertex is the point negative 3, negative 49. Now in part D, it says, how could we find the y-intercept where the graph crosses the y-axis and x equals 0? So reminding you that a y-intercept means that the x value is 0. So we know x is 0. We have to find y. So we'll use the factored form again. X plus 10 and x minus 4 is going to be equal to y. I'm just writing it. You could have written y equals instead of equals y. We know that x is 0 because we're on the y-axis. So I'm going to put a 0 in x's spot. 0 plus 10 would be 10. 0 take away 4 would be negative 4. So that means negative 40 is our y value. So that tells me that our y-intercept is an x-coordinate of 0 and a y-coordinate of negative 40. So now moving on to part E, what else can we say about the graph based on our knowledge of the symmetrical nature of the graph of a quadratic function? Can we determine the coordinates of other points? So we're going to create a table of values to organize what we have so far and see what the symmetric property will get us. Okay, so we have x and f of x. And we're going to just kind of start plugging things in. So let's make some places for our values. Now, based on what we have already, if I go back and take a look, we already found the vertex is negative 3, negative 49. And that should be in the middle because the vertex is the turning point, the point where that turns symmetrical. Okay, so right in the middle, so on the third line down, we're going to put negative 3 and negative 49. This is our vertex. So that's why I'm putting that in the middle. Now we also have roots of 4 and 0. We know we have a y-intercept of 0, negative 40. So we got to start putting these things in there. So if I'm thinking of where these should land, my y-intercept was 0, negative 40. So I'm going to put that above 0, negative 40. This was our y-intercept. Then we also had roots of 4, 0 and negative 10, 0. So I can tell that my 4, 0 is going to go in the first position based on the way that we have the table set up, 4, 0. This is one of the roots. Now for the symmetric property, I know the other root must be at the very bottom. So that's negative 10, 0. That's our other root. So the only point we really don't know with the symmetric property would be this point that goes right in here. Okay, so we know we have to find that symmetric piece that's between the vertex and the root. So using that symmetric property, we have to make sure we pick a point that makes sense to go in this position that is going to satisfy that symmetric property. So we know negative 40 is going to go here. We just have to figure out how far away we need it to be here. Well, 0 is 3 away from negative 3. So we need to go 3 away from negative 3 in the other direction, which would be negative 6. And now we can figure out this point as well using our symmetric property. So now in part F, we're going to actually plot these points for the equation on our graph paper. So we're just going to take these coordinates and plot them. We have 4, 0, and we also have negative 10, 0. So those are our two roots. We then have 0, negative 40, which is here. We also have negative 3, negative 49, so negative 3, and then just below negative 48 will be negative 49. Be careful of your scales here. Also have negative 6, negative 40. So you can see that symmetric property take shape. We're going to create that curve, arrows on the end, and then we're going to label it with f of x. So in example 2, a science class designed a ball launcher and tested it by shooting a tennis ball straight up from the top of a 15-story building. They determined that the motion of the ball could be described by the function h of t equals negative 16t squared plus 144t plus 160, where t represents the time the ball is in the air in seconds and h represents the height in feet of the ball above the ground. What is the maximum height at the ball at what time will the ball hit the ground? So we're going to answer these questions by going through our different parts. It says A, with a graph, we can see the number of seconds it takes the ball to reach its peak, and also how long it takes to hit the ground. How can factoring the expression help us graph this function? Now remember what factoring does. You set the equation equal to 0, and you solve for x's. If you're solving for x's, that means you're finding the roots. So it will help us find the roots of the graph. So in part B, once we have the function in its factored form, what do we need to do in order to graph it? Now graph the function. So let's take a look at our actual expression here, negative 16t squared plus 144t plus 160. We want to factor this. So the first thing we should look for is the greatest common factor. So if I look at that, negative 16 goes into all three of those. So I'm going to take out a negative 16. Now, why negative and not just 16? Remember, in order to factor, we want the leading coefficient to be a positive number. So negative 16, this will be t squared minus 9t minus 10. Now we have a trinomial we can factor into two binomials. We want the factor pairs of negative 10 that would add up to negative 9. So that's going to be minus 10, t minus 10, and t plus 1. We can create a table of values, t and h of t. And we can kind of use the same ideas that we used in the previous problem to start creating this table of values. I know that if I were to set this equal to 0 and find the roots, I'd be taking t minus 10 and equaling it to 0. And I'd be taking t plus 1 and equaling it to 0. So I'm actually going to come down here and do a little bit of the work. We're going to do negative 16 times t minus 10 times t plus 1 equals 0. We're going to do our t time. We get negative 16 equals 0, which we know we cannot have, so we're going to slash that equal sign. We have t minus 10 equals 0, where we're going to add 10 to both sides and get t equals 10. And then t plus 1 equals 0. We're going to subtract 1 and get t equals negative 1. Now, if this is a problem about time, t equals negative 1 is not going to make sense, so we are going to reject that answer. But it is going to help us when we go to graph so that we know what our roots are. So when I start to set up this table of values, my roots were 10 and negative 1. So I'm going to have negative 1 be at the top here with negative 1, 0, and 10, 0 would be at the bottom. Those are our two roots. So now we just want to fill in the other pieces that we will do gradually here. We need to find the y-intercept, which we can find from the problem. When I look at the equation, the number at the end is the height of the ball. We know that because if I were to plug in t equals 0, negative 16t squared and 144t would all wipe out, and we'd have that h of 0 equals 160. So the next point that I definitely know is 0, 160. That is our y-intercept. Now, as far as the symmetric property goes, we should then be able to fill this in with 160. So negative 1 was only 1 away from 0. So we have to make sure that we're 1 away from 10 lower. So 9, 160 is going to be our symmetric point. So far we have almost all the coordinates we need. I know it tells us to graph, but let's keep moving forward to see if we can find out other information. So it says using the graph, at what time does the ball hit the ground? We'll come back to that. It says D, over what domain is the ball rising? Over what domain is the ball falling? We'll come back to that. E says, using the graph, what is the maximum height that the ball reaches? Now, when we're talking about the maximum height that the ball reaches, the max here, because we have a negative A value, our quadratic is going to open down. We know that. So our max is going to be a height, and it's going to happen right at the vertex. So we need to figure out the vertex. Now, there's a couple different ways you can do this. What I would like to use is the axis of symmetry formula to remind you of how to use that. Usually it's x equals negative b over 2a, but we don't have x's, we have t, so we'll use t instead. So going back to our equation, the b value is 144. So we have negative 144. And then that goes over 2 times a. Our a value was negative 16. So that means t, if you take negative 144, and then this would be negative 32, and you divide those, you get 4.5. Now that's just going to give us the line, the vertical line that cuts it in half. Remember, we still have to then find out what that height is. So using the factored form, I'm going to do negative 16, t minus 10, t plus 1, and then equals h this time because we want to find out what the height is. We're not going to make it equal to 0. Every time I see a t, I'm going to put in 4.5. And now I can do that math to see that the height ends up being 484. So now I have the point that I can put in for my vertex, 4.5 and 484. So now I want to take and create this graph. So we've got t and h of t. We know that our first point is going to be negative 1, 0, but we don't really need to plot that because it's not a part of this problem. We're only concerned with positives. It just helped us get the symmetry of the table. Then we have 0, 160. So each of these blocks is worth 25. So you want to be just a little bit above 150. Then we have 4.5, 84. So 4.5 and then 484. Sorry, 450, 475. So we're kind of up here looking at 484. Then we have 9, 160. So you again want to be just a little bit above 150. And then we have 10, 0. So we're looking at a shape like this. No arrows on either end. We're going to label this as h of t. We don't want any arrows because we're not going to go back into negatives in either direction. So now we can go back and answer the questions C, using the graph, at what time does the ball hit the ground? We want a h of t value of 0, so that's going to happen at t equals 10 seconds. Then D, over what domain is the ball rising? So we're on the upswing all the way up till that axis of symmetry at 4.5. So it's rising from 0 less than t and less than 4.5. We're going from 0 to 4.5. Now remember, when we're doing intervals of increasing and decreasing, we do not include the numbers. So there should be no or equal to. When is it falling? Well, we're falling from that 4.5 mark all the way down to 10. So we're falling from 4.5 less than t less than 10. And that concludes our lesson on graphing quadratics in factored form.